In a previous video, screws provided 2 to 3 times more holding power over nails, making them the perfect choice for many small projects. But what about shear strength? Obviously, shear strength has to be considered for many applications, such as house framing. Well, today we'll be testing shear strength for nails and screws to see which one is the best. We'll compare shear strength in 2 separate tests. We'll also take a look at metal fatigue for both screws and nails. In the first test, we'll attach 2 boards, both untreated 2x4s, using 2 fasteners. I'll use a jig to make sure the nails and screws are driven in at the same angle every time and equally spaced apart. Once the nails and screws are in position, I'll attach a puller arm to the test piece and then place the test piece in position for testing. Once the testing begins, an upward force will be applied to measure how much force it takes to separate the 2x4s. We'll test each type of fastener for a total of 3 times. We'll begin testing with the 16-penny galvanized spiral shank nail first. While it's designed for patios and decks, which is typically a harder type of wood than we'll be testing, it'll be interesting to see if the spiral design helps. It's very hard to determine exactly when a fastener is beginning to lose grip. Since it's highly subjective, I'll provide that information along with the maximum force required to pull the boards apart. In the first test, movement began at 118 pounds, but it took a total of 405 pounds to separate the boards. The second one moved at only 50, but required a max force of 323 to separate the boards. The third did a little bit better with movement at 86 and a max force of 394. 16-penny coated nails are typically used for general construction and framing. Let's see how they compare to the spiral shank nails. The first moved at 328 with a max force of 441, which is better than all 3 tests with the spiral shank nail. The second moved at 363 with 447 max force. The third moved at 146 and 384 max force, which is much lower than the first 2 nails. The 16-penny 3.5-inch ring shank design makes it ideal for load-bearing structures such as pole barns. The first nail moved at 404 pounds with a max force of 648, beating both the spiral shank and the coated nails. Very impressive. The second didn't do quite as well, moving at 369 with a max force of 594. The third did a little bit better, requiring 386 with a max force of 561. Impressive results for sure. The 16-penny smooth shank galvanized nail showed a lot of holding power in the previous test, but will the galvanized coating help in this test? The first one moved at 308 pounds with a max force of 400, which isn't nearly as good as the ring shank nails. The second one didn't do quite as well as the first, moving at 189 with a max force of 377. The third moved at 174 with a max force of 421. Drywall screws might have great holding strength, but can they handle this type of force without shearing? The first moved at 305 with a max force of 986. Wow, I'm surprised the drywall screws held up. The second did even better at 545 with a max of 1,199. The third didn't do quite as well, but still did great with 465 and a max force of 1,023. However, the weakness of using drywall screws for construction has just been exposed as one of the drywall screws sheared off. A lot of viewers requested that GRK number 10 multi-purpose screws be included in this test. While these are 3 1/8 inches in length, which is shorter than the other fasteners we're testing, viewers requested these since they are building code approved screws for some applications with a rated shear load of over 1,000 pounds force. They look great on paper, but let's see how they can do in this test. The first moved at 305, but the max was 791. Very impressive. The second didn't do quite as well, moving at 335 and 572 max force. The third did slightly better at 342 with a max force of 660. None of the screws sheared off during the testing. When previously testing deck screws, they demonstrated amazing holding power over all the other fasteners, but can they survive this type of force being applied in this grueling test? The first moved at 365 with a max force of 907. The second did very well at 387 with a max force of 825. The third didn't move until 454 with a max force of 854. Unlike the drywall screws, none of the deck screws broke. The wood failed, not the screws. The goal of this next test is to see just how tough these nails and screws are. So what we're going to do is use this puller arm, drive a nail in the center of this board all the way in, and then pull up on the puller until each nail and screw is extracted or the head breaks off. This jig will allow us to get the nail or the screw in a perfect vertical position as well as centered on the board. We'll test the 16-penny galvanized spiral shank nail first. The first nail sheared off at 373 pounds. The second nail didn't do nearly as well at only 191. The third did much better at 310 pounds. The puller is really putting the structural integrity of each fastener design to the test. Will the 16-penny coated sinkers do any better? The first required 310 pounds to extract the nail from the board. The second did even better at 322. The third did nearly as well at 314, so the coated sinkers delivered very consistent results without any instances of the nail breaking. Will the ring shank nail with its incredible holding power break in the same way as the spiral shank? Let's find out. The first ring shank required 516 pounds, very impressive. The second ring shank did even better at 639. The third did nearly as well at 603, and none of the nails broke into two pieces. Can the galvanized smooth shank do as well as the ring shank? The first galvanized required 355 pounds of force. The second did even better at 370. The third did even better at 470. None of the nails broke into two pieces. In the previous test, one of the drywall screws broke into two pieces. Can the drywall screw handle this type of force? The first drywall screw took an impressive 734 pounds to remove. The second was nearly the same at 732. The third was the best at 781. Known for being very brittle, I'm really surprised that these drywall screws didn't break. Even though the GRK screws aren't as long as the drywall screws, can they deliver as much strength? The first GRK required 695 pounds to be extracted. The second did even better at 766. The third did nearly as well at 719, very impressive performance. As you can see, the GRKs did bend, but none of them broke into two pieces. Deck screws are also known for being brittle, so can they survive this test? The first screw required 840 pounds, the most amount of force of all the fasteners tested. The second was down some to 706. The third was down a little bit more to 612. Just like the GRKs, the deck screws held up just fine. Up until this point, we've demonstrated the ability of fasteners to withstand a single direction bend. In modern construction, fasteners need to be able to withstand some recurring shifting back and forth. This next test will demonstrate the risk of using brittle fasteners over ones that are more ductile. So the tester has two different size holes. One hole is designed for screws, and the other hole is designed to fit nails. So it took a total of 6 bends in order to shear off this nail. Okay, the cutted nail also sheared off with 6 bends. Wow, the ring shank nail broke on the second bend. Okay, it broke on the 8th bend. Okay, the drywall screw. Okay, just push once on the drywall screw and it's sheared off. Any sort of lateral movement with the drywall screw is going to cause a significant issue with shearing. Okay, testing the GRK fastener next. Okay, that took 2 bends in order for it to break. So about the same as the ring shank nail. Okay, deck screws. The deck screws failed on the second bend. Coated sinkers and drywall screws are very affordable, but if weather exposure or use in pressure-treated lumber is a factor, it's worth spending a little bit more money on galvanized or properly treated fasteners. In the very first test, which is very subjective to interpretation, the drywall screws came out on top for requiring the most amount of force before the boards began to move. As we saw later in the testing, drywall screws are unlikely to provide a lasting solution where shear force is a factor since they are brittle and could suddenly fail. The deck screws barely came out ahead of the ring shank nails, and the ring shank nails actually came out ahead of the GRK fasteners. A much more objective way to look at the first test results is to consider the amount of maximum force required to separate the two boards. Once again, the drywall screws came out on top, followed by the deck screws, then GRK, and finally the ring shank nail. In the second test, in which a single nail was driven into the end of a 4x4 board, the 3 types of screws beat the nails, requiring between 719 and 749 pounds. The ring shank nail, which is very brittle like the screws, required 586 pounds for removal. While the screws performed better than the nails in the short-term test, the final test demonstrated how brittle fasteners can fail quickly with repeated motion, while fasteners that are more ductile will do a lot better job withstanding movement. A big thank you to everyone requesting we do shear strength testing. I learned a lot from each of these videos, especially trying to design the test. It can be rather challenging at times, trying to figure out how to set up the test jig in a way to get repeatable, accurate results. Anyway, I'm always looking for future video ideas. All my video ideas come from viewers, and I do read every comment and I reply to as many as possible. As usual, just want to say thanks so much for watching the video. Please take care, and I look forward to next time.